Recording has started.
So yesterday we looked at scientific notation and converting numbers into scientific notation and engineering notation. Today we're going to look at operations with scientific notation in engineering. Remember when we add and subtract, we need the same name. And of course we combine counts. And we keep the same name. Well, with whole numbers, that name was the place value. We lined up the columns and we added and subtracted down the columns. If I have scientific notation like 4.8 times 10 to the ninth, the part of that that implies a place value is the 10 to the ninth. That is the name. The 4.8 then is the count. So if I go to combine numbers in scientific notation, I have 4.8 times 10 to the ninth. Now these parentheses here are not an enclosing symbol. It's not telling us to do anything there first. It's just separating that number out from the rest of the problem. So 4.8 times 10 to the ninth plus 3.4 times 10 to the ninth. So these both have the same name. They're both 10 to the ninth. We'll combine the counts. 4.8 plus 3.4 is 8.2. And we keep the same name, times 10 to the ninth. Now we might have something like 7.3 times 10 to the 13th plus 6.5 times 10 to the 13th. These have the same name. They are both 10 to the 13th. We're going to combine the counts. 7.3 plus 6.5 is 13.8. Then we keep the same name, times 10 to the 13th. Now there's an issue with this answer. Because for proper scientific notation, we can only have one digit in front of the decimal point. I have to move this decimal point over there to make that a 1.38. If I move the decimal point, I have to adjust the power of 10. I made this number smaller by one decimal place. It went from 13.8 to 1.38. So that number, the count got smaller, the name has to get larger. So 13 plus 1 is 14, so it's 10 to the 14th. We need to be careful with these when we hit our negative powers. We might have 8.4 times 10 to the negative ninth plus 6.9 times 10 to the negative ninth. We have the same counts. They're both 10 to the negative ninth. So we're good there. Same names, I should say. They're both 10 to the negative ninth. So we'll combine the counts. 8.4 plus 6.9 is 15.3. And we keep that same name, times 10 to the negative ninth. Now, once again, we have two digits in front of our decimal point. So we have to move that decimal point over to make that 1.53. That number got smaller, went from 15.3 down to 1.53, so our name gets larger by 1. Negative 9 plus 1 is a negative 8. Be very careful with those negative powers. What if we start out with two numbers that don't have the same name? What if we have something like 7.68 times 10 to the 13th plus 9.4 times 10 to the 12th. Well, we have different names here, 10 to the 13th and 10 to the 12th. We have to change them to be the same name. Either this is going to have to become 10 to the 12th, or this will have to become 10 to the 13th. Typically, if we are adding, we want to go to the larger power. So the 7.68 times 10 to the 13th isn't going to change. We're going to change this to times 10 to the 13th. Now it's just the opposite of before moving our decimal point. Here, the name got larger by 1. The number has to get smaller by a place value. That is 0.94. And now we can add 7.68 plus 0.94 is 8.62 times 10 to the 13th. Subtraction has very similar attributes. So let's take 8.2 times 10 to the 11th minus 3.9 times 10 to the 11th. Again, we have the same name. Both are 10 to the 11th. We combine the counts. 8.2 minus 3.9 is 4.3. Now we keep the same name, times 10 to the 11th. I might have 6.42 times 10 to the 16th minus 5.97 times 10 to the 16th. Again, we have the same name, so we're going to combine the counts. 6.42 minus 5.97 is 0.45. And we keep that same name, times 10 to the 16th. Now, once again, we have improper scientific notation here. We have only zeros in front of our decimal point. So here we have to move the decimal point the other direction to make that 4.5. Well, in this number, the count got larger, so the name gets smaller. 16 minus 1 is 15, so that's 4.5 times 10 to the 15th. Again, we need to be careful with negative powers. $7.38 times 10 to the negative 9th minus 6.92 times 10 to the negative 9th. We subtract the counts. 7.38 minus 6.92 is 0.46. We keep that same name, times 10 to the negative 9th. So once again, we move that decimal point over to make that 4.6. The number got larger, the power gets smaller. So negative 9 minus 1 is a negative 10. That's 4.6 times 10 to the negative 10. When we multiply or divide, remember we do not need the same name. So we do not have to have the same power of 10 to start out with. As always, we're going to combine the counts. Then we're going to also combine names. This looks a lot like our algebraic numbers we were working on just last week. We might have something like 6.2 times 10 to the 14th times, let's do 1.5 times 10 to the 8th. We do not have the same name, and we don't need the same name because we're multiplying. We're going to multiply the count. 6.2 times 1.5 is 9.3. Then we also combine the names. 10 to the 14th times 10 to the 8th. I add powers. 14 plus 8 is 22. That is 10 to the 22nd. I might have 5.9 times 10 to the negative 13th times 3.8 times 10 to the negative 7th. Again, I'm going to combine counts. 5.9 times 3.8 is 22.42. Then I combine the names. 10 to the negative 13th times 10 to the negative 7th. I add powers. Negative 13 plus negative 7. That's 10 to the negative 20th. I have to move that decimal point over because there's 2 decimal places in front of the decimal right now. That'll be 2.242. That number got smaller, so the count got smaller, the name gets larger. Negative 20 plus 1 is a negative 19. So 2.242 times 10 to the negative 19. Or we might have 6.5 times 10 to the 12th times 3.4 times 10 to the 6th. Well, again, we combine the count. 6.5 times 3.4. $22.1. Now we combine the names. 10 to the 12th times 10 to the 6th. Again, we're adding powers. 12 plus 6 is 18. That's 10 to the 18th. Well, once again, we have 2 digits in front of the decimal point. We're going to move it over. Make that 2.21. The count got smaller. The name gets larger. 18 plus 1 is 19. Division. I might have 2.21 times 10 to the 19th divided by 3.4 times 10 to the 8th. So I divide 2.21 divided by 3.4 is 0.65. I also combine the names. 10 to the 19th divided by 10 to the 8th. I'm subtracting powers here. 19 minus 8 is 11. That's 10 to the 11th. Now this one has only zeros in front of the decimal point, so we have to move the decimal point over 1 spot. Make that 6.5. The count got larger, the name has to get smaller. So that'd be 10 to the 11 minus 1 is 10. So 6.5 times 10 to the 10th. We might have 5.76 times 10 to the negative 5th divided by 4.8 times 10 to the negative 15th. 5.76 divided by 4.8 is 1.2 times 10 to the negative 5th divided by 10 to the negative 15th. I'm subtracting powers. Negative 5 minus a negative 15 is negative 5 plus a positive 15. That's 10. That's 1.2 times 10 to the 10th. If I have 1.2 times 10 to the 8th to the power of 3. Just like with our algebraic numbers, I take the count to the power of 3. 1.2 to the power of 3 is 1.728. And then I do the name to the power of 3. 10 to the 8th to the power of 3. Well, when I do a power, I multiply powers. So 8 times 3, that's 10 to the 24th. Let's do 6.4 times 10 to the 12th to the power of 4. So we do 6.4 to the power of 4. So 1,677.7216. Times our 10 to the 12th to the 4th power. We multiply powers. 12 times 4 is 48. Now here, we have 4 digits in front of the decimal point. We need to move it over 1, 2, 3 spots to make that 1.6777216. The count got smaller. The number has to get larger. The count got smaller by 3 places, so the name gets larger by 3. So 48 plus 3 is 51. So that's 10 to the 51. We looked at things like this for algebraic numbers, the square root of 5.76 times 10 to the 12th. And just like with the algebraic numbers, we take the square root of the number. The square root of 5.76 is 2.4. And then for the names, we divide the power by 2 because this is a square root. So 12 divided by 2 is 6. That's 2.4 times 10 to the 6th. I could have a third root. I might have 1.728 times 10 to the negative 21. The third root of 1.728 times 10 to the negative 21. So I do the third root of 1.728, which is 1.2. The third root of 10 to the negative 21. Now I divide the power by 3. Negative 21 divided by 3 is negative 7. So that's 1.2 times 10 to the negative 7. Let's talk just briefly about engineering notation. One of our main formulas in electricity is voltage equals current times resistance. Well, if our current is 40 microamps and our resistance is 2 kiloohms, the voltage will be the 40 microamps times the 2 kiloohms. Well, as that's written, that can be very difficult to multiply out. In fact, a lot of people would just put it out to their decimal equivalent and then multiply it from there. But we can do the operations with the metric prefixes. Micro is 10 to the negative 6. So that is 40 times 10 to the negative 6 amps. Kilo is 10 to the third, so that is 2 times 10 to the third ohms. We combine the counts. 40 times 2 is 80. We combine both of the names. 10 to the negative 6 times 10 to the third is 10 to the negative 3. An amp times an ohm is a volt. I wouldn't expect you to know the amp times an ohm is a volt, but for now, at least know the metric prefixes. The 10 to the 6 times 10 to the third is 10 to the negative 3. And of course, 10 to the negative 3 is milli, so this is 80 millivolts. So the engineering notation does have its place in there. Okay, so for homework, out of the big book. Page 250, exercise 6-11C. And page 255. Exercise 6-12C. And of course, just the odds in those.